Here in this class, I'm discussing with you related to the escape velocity. Escape velocity. Escape velocity means the velocity, the minimum velocity of the body for which the body is projected. It enters into the space by overcoming the gravitational pull. By overcoming the gravitational pull. As you know well, if you throw a body vertically upwards, then it reaches to some height and again coming towards the ground. But here the topic is nothing but the word itself has the clear meaning: escape velocity. The body should be travel in such a way that it has to escape from the gravitational atmosphere. So it means the body thrown upwards, it reached to some height, and again it never come back to the ground. It never come back to the ground. It means the nature of the any planet is, if a body thrown upwards, every planet has its own gravitational force. So again the body moves towards the surface of the planet. Now we are onto the surface of Earth. The body is thrown upwards from the surface of the Earth in such a way that it has some minimum velocity. That minimum velocity here I am taking it as VE. The minimum velocity is taken as here VE. That VE is nothing but escape velocity. If your body is projected with this velocity, with this escape velocity, the body never returns to the ground, never returns to the surface of the planet. It means what? It overcomes the gravitational pull. It overcomes the gravitational force of attraction of the planet. It enters into the space. Once the body enters into the space, then we used to say that the minimum velocity with which the body is projected upwards is known as escape velocity. Okay, so this escape velocity is having the formula VE is equal to root over 2gm by r. VE is equal to, what's the formula? Root over 2gm by r. So what is the escape velocity of the body if you projected from the surface of the earth? The escape velocity for a body onto the surface of the earth is 11.2 kilometer per second. 11.2 kilometer per second. It means if the body is projected in such a way that per second it has to travel 11.2 kilometers, minimum 11.2 kilometers, then only the body overcomes the gravitational pull and enters into the atmosphere. So now enters into the space. Okay, now here the formula, general formula is VE is equal to, what's the formula? Root over 2gm by r. So as already you know that the relation between the acceleration due to gravity and the gravitational constant, universal gravitational constant, is G is equal to Gm by r square. Then with that, here in the denominator r square we have r into r I am taking. Just take the cross multiplication, gr is equal to, what's the value? Gm by r. Gr is equal to Gm by r. Now in the place of Gm by r, I am substituting gr. Now new formula of escape velocity VE is equal to 2 as it is Gm by r. Gm by r replace with what? Zr. So VE is equal to root 2 Zr. VE is equal to root 2 Zr. Okay, like this we used to consider the escape velocity. So here in the same way, related to the escape velocity in the form of density, we used to take the formula VE is equal to root over 2. In the form of density, if you want to calculate the escape velocity, 4 by 3 pi r rho g into, what's the value? Into capital R. into capital R. Like this, we used to consider the concept of escape velocity. How we got this formula? Already I said this formula at the time of taking the concept of the factors which are affected the acceleration due to gravity, and those factors are, one is altitude, depth, like that I said to you. Okay, in the concept depth, the acceleration due to gravity, small g, is having the formula 4 by 3 pi r rho z. 4 by 3 pi r rho z. This is the formula which we have in the case of acceleration due to gravity at depth d. Now, in the place of small g, we consider 4 by 3 pi r rho z. As it is in the place of capital R, we wrote capital R. So this, based on this, they asked in NEET 2021. In NEET 2021, based on this, they asked the one question in the NEET 2021 question paper. Okay, just focus on this. So here the formulae are not much complicated. Whatever formulae we know well, in that formulae only they used to ask the questions actually. So related to one particular lesson, if you are confined to particular formulae, then only you will get the grip of doing numericals in that particular lesson. That's why, so these are the weightage lessons actually, system of particles and rotatory motion. And then this one is also gravitation. The other one, oscillations. Oscillations and waves mixed up, and they used to ask in the NEET actually. So in general, and these are very, very important and very easy to do the numericals also actually. So focus on this properly. Escape velocity, VE is equal to, in the form of density, this is the formula. General formula is VE is equal to root over 2 ZM by R, that is equal to root 2 ZR. And based on this, in 2021 question paper, they asked the question. Okay, now another one is nothing but here. For example, this is the planet. This is the planet. Okay, radius of the planet is R. The mass of the planet is capital M. Now, the body is at a h height from the surface of the planet. H height from the surface of the planet. So what is the mass of the body? The mass of the body is small m. Now what is the distance of the body from the center of the planet? What is the distance? The total distance of the body from the center of the planet is r plus h. So from here, if the body wants to be projected, what is the escape velocity from here? So that is VE is equal to root over 2 gm by root over 2 gm by r. Here, if you are taking the r, what is the meaning of that? The body is onto the surface of the planet. If you are taking the r plus h, it means the body is at a h height from the surface of the planet. So like that, we used to take the formula of escape velocity if the body is at h height from the surface of the planet. Okay, now, and based on this, they used to ask in different years, 2001 MSET, 2006 MSET medical entrance, and 2013 also medical entrance. They asked this question related to this formula. VE is equal to root over 2 gm by r plus h. Okay, now next we are taking further the escape velocity. Already I said to you that the escape velocity on the surface of the earth is 11.2 kilometer per second, and whereas escape velocity on the surface of the moon, escape velocity on the surface of the moon is 2.31 kilometer per second. 2.31 kilometer per second. It means what? It means what? From the surface of the moon, if any body or particle can be projected with this velocity 2.31 kilometer per second, then that body overcomes the gravitational pull of the moon and enters into the space. Nothing but out of the moon the body can be entered. Okay, that is the meaning of this velocity 2.31 kilometer per second. Okay, and then here this is about escape velocity, and based on this we have numericals, I'll tell you later. And then orbital velocity. orbital velocity. What is the orbital velocity? Just now we consider the escape velocity. It means just the body enters into the space. After entering into the space, the body rotates around the Earth or around the planet in the orbit, in the particular orbit. So when it rotating, or when the body is rotating around the planet in the particular orbit, it must and should possess some velocity. That velocity in the orbit is known as orbital velocity. It means what? And this is the Earth. This is the Earth. Around the Earth, a body is rotating in the orbit. When the body is rotating in the particular orbit, then this body, for example, satellite, the satellite is revolving around the Earth. So that satellite is having some velocity. That velocity is known as orbital velocity. That orbital velocity here we are naming it as V naught. V naught. So here you need to know one topic. If any body is rotating another one, about another one, then two factors come into the picture. One factor is gravitational force. The other factor is centripetal force. If the body is in rotational motion, it must and should possess one force that is known as centripetal force. So when the centripetal force is acquired by the body, then only that body is in rotational motion around the another body. Got it? Now, here we are taking that the satellite or the body is revolving around the Earth, nothing but around the planet. So it means what? The gravitational force must be equal to centripetal force. The gravitational force must be equal to centripetal force. Then only we will get the concept of orbital velocity. The orbital velocity V naught is equal to, what's the formula? Root over gm by r. Here, what is the capital M? Capital M is the mass of the planet. Capital M is the mass of the planet, and r is nothing but radius of that orbit. Radius of that particular orbit. Okay, now V naught is equal to, what's the value? Root over gm by r. Root over gm by r. At h height, same consideration. At h height, V naught is equal to, what's the formula? Root over gm by r replaced with what? R plus h. R replaced with r plus h. V naught is equal to root over gm by r plus h. Okay. Now, once you know that V naught is equal to root over gm by r plus h, then further we are taking the concept it as, generally you know one thing, G is equal to, what's the formula? Gm by r square. One more formula here we are taking, cross multiplication. G into r square is equal to Gm. Cross multiplication. G into r square is equal to Gm. So now substitute in the place of Gm as gr square. Now the new formula of orbital velocity V naught is equal to root over gr square by r plus h. V naught is equal to root over gr square by r plus h. Just take a look on this topic. If a planet or if a body is rotating around another planet or another body, the gravitational force must be equal to centripetal force. So with that, we can solve this part. V naught is equal to root over gm by r. Okay, solving this V naught is equal to root over gm by r is nothing but that is like our intermediate board exam question, 4 marks question. So that we don't know now. We don't want now. So V naught is equal to root over gm by r at h height. If you are taking h height, then V naught is equal to r replaced with r plus h. As you know the formula, G is equal to gm by r square. Gr square is equal to gm. Then take the cross multiplication. V naught is equal to root over gr square by r plus h. V naught is equal to root over gr square by r plus h. Okay, now listen. Here, once the body is rotating in the orbit, here we need to consider angular velocity. We need to take the angular velocity. How come we calculate the angular velocity? Angular velocity, nothing but here we know one relation. V is equal to R omega. The relation between the linear velocity and angular velocity is V is equal to what? R omega. We required omega. Omega is equal to what's the value? V by R. That I am taking it as V nothing but V naught. R is nothing but R plus H. R is nothing but R plus H. Why? Because, and this is the planet. This is the planet Earth. Around the Earth at H height. Around the Earth at H height, another body is rotating in the particular orbit. In the particular orbit. So radius of the Earth is R, and total height from the center of the planet is nothing but R plus H. This itself is, here we are taking it as small r. Small r is equal to R plus H. Now V naught is equal to, just now we considered that 1 by R plus H as it is, I am mentioning here. V naught is equal to, what's the formula? Root over Gm by R plus H. Now omega is equal to root over Gm by, send this R plus H into the square root. R plus H into the square root. Then what it happens? If it is out of the square root. If you enter this one into the square root, this became a square. And R plus H whole square it forms. Already one more R plus H is inside the square root. Then it became as R plus H whole cube. It became as R plus H whole cube. Omega is equal to root over Gm by R plus H whole cube. And this is the angular velocity. Angular velocity of revolving orbit. Revolving body in the orbit. Revolving body in the orbit. Okay, now the next one is nothing but time period. We need to calculate time period. Time period is equal to T is equal to, how come we consider that? Time period is equal to T is equal to 2 pi by omega, general formula. Remember carefully, whenever time period is mentioned, that can be considered with capital T. What is the meaning of time period? Time taken by the body to complete one oscillation or one revolution or one rotation. Here, rotation. Time taken by the body around the planet to complete one rotation is known as time period. 2 pi by omega. Already we calculated the omega. Omega is equal to root over Gm by R plus H whole cube. So with that, capital T is equal to, what's the formula? 2 pi by this entire value in the denominator. So the fraction can be reversed. 2 pi root over R plus H whole cube by Gm. 2 pi root over R plus H whole cube by Gm. Like that, we consider the time period of the revolving body in the particular orbit. Okay, now see, like this we used to consider, how come we get the relation between the angular velocity as well as the radius, angular velocity as well as the radius, as well as time period as well as the radius. Based on this, in the year 2012 as well as 1993, they used to ask in the medical entrance. Okay, so now here we are taking that T square proportional to R cube. This is the relation, T square proportional to R cube. This is also, we are taking it as Kepler's third law, T square proportional to R cube. Okay, so next one, here we are taking that in the same way. In the same way, we used to take it as this is the relation between the time period and the radius. Relation between the angular velocity and the radius is nothing but omega square is inversely proportional to R cube. Omega square is inversely proportional to R cube. Like that, we used to consider. Based on this, in 1996 as well as 2012, they used to ask in the medical entrance examinations. Okay, then another one. Listen. So here we are taking the concept as two satellites are considered, and those two satellites are revolving around the Earth. So nothing but simply we used to take it as around the planet. Two satellites are revolving around the planet in different orbits. In different orbits. So different orbits, nothing but for example, this is the Earth. This is the Earth. One planet is revolving like this. Another planet is revolving like this. Now this is R1. Then another planet is having the radius is R2. The circular orbit of first one is R1. The circular orbit of the second one is R2. Then we need to take the relation between these values. Okay, so for that here we are taking that this particular body is revolving in the particular velocity in the orbit v1, and this body is revolving in the particular velocity v2, and this body is at h1 height from the surface of the planet, and another body is revolving at h2 height from the surface of the planet. Nothing but two different bodies are revolving around the earth in two different orbits in such a way that at different heights those two bodies are revolving or rotating. So when the bodies are rotating like this, then immediately we used to take it as r1 is equal to r plus h1. Remember, in this gravitation at h height or h1 height, if the bodies are rotating, it means from the center of the planet we need to consider the distance. So radius of that particular planet plus height from the surface of the planet. R1 is equal to r plus h1. R2 is equal to what's the value? R plus h2. Okay, now V is equal to, what's the formula? Root over Gm by R. V is equal to root over Gm by R. What is the relation between the velocity, orbital velocity, and the radius of the orbit? Inversely. So V is inversely proportional to root R. V is inversely proportional to root R. Why? Because R is in the denominator. So here itself I am writing the formula. V is inversely proportional to root R. So V1 by V2 is equal to, it is in the denominator, no? So first take the second term, after that first term, root over R2 by R1. Okay, now V1 by V2 is equal to root over R2. What is the value of R2? What's the value of R2? R plus H2. What is the value of R1? R plus H1. So now here I'm writing that R2 R plus H2 by R plus H1. V1 by V2 is equal to root over R plus H2 by R plus H1. Like this, we can solve this. Based on this, in the year 2010 and 12, they asked in the medical entrance based on this formula. So observe, while I'm saying number of years, in which year, which topic is coming, which formula is coming, I'm saying that means what is the inner meaning inside that? What is the inner meaning? The inner meaning is how important having by this lesson. How important. Okay, so just take a look on this and then work thoroughly, and surely you will get the success. Next. Then another one here based on that, this is about the escape velocity as well as the orbital velocity. Once a body is rotating around another one in the particular orbit, there existence of another physical quantity. That another physical quantity is angular momentum. What is the another physical quantity? Angular momentum. Angular momentum represented with L. So what is the relation between the angular momentum and the radius of the circular orbit in which the body is rotating? And that is L is directly proportional to root R. Remember this. L is directly proportional to root R. Okay, so like this, we used to consider the concept of angular momentum briefly. The relation between the angular momentum of the revolving body and the radius of the circular orbit is L is directly proportional to root R, right? So now the another one is nothing but here we are taking the concept of energy of the satellite. Energy of the satellite. So it means what? If the satellite is revolving in the particular orbit, if the satellite is revolving in the particular orbit, then that must and should possess energy. Must and should possess energy. So that total energy as well as potential energy and kinetic energy. So at first I'm taking the total energy. This is very, very important. The total energy of the satellite. Total energy is nothing but it is the sum of the kinetic energy and potential energy. Kinetic energy and potential energy. Okay. So the total energy of the satellite is minus G capital M small m by 2 into R plus H, minus G capital M small m into 2 into R plus H. So based on this, in 2009, 2005 as well as 1991, they asked the question based on this total energy of the satellite. Okay, now listen. See here, when the satellite is revolving around the Earth, then the orbital velocity is V naught is equal to root gr. You know well, V naught is equal to root gr. Orbital velocity. Orbital velocity is equal to V naught is equal to root gr. Root gr. Okay. Now, what is the escape velocity? Escape velocity is equal to, you know well, what's the formula? VE is equal to root over 2gr. VE is equal to root over 2gr. Okay, so if these values are not having by the orbital velocity or not having by the body, what happens? The uh, circular path of the body. What happens to the rotatory motion of the body? That we need to know. So if the body is having a v velocity less than root gr, that body falls onto the surface of the planet again, falls onto the surface of Earth. So if the orbital velocity is less than root gr, so minimum velocity possessed by the body is root gr. Less than root gr, if the body is possessing in the particular orbit, then it falls onto the surface of the Earth. Okay, and then so if the body is moving with v is equal to root gr, just now we considered that. What's that? That body is in the circular orbit. That body is in the circular orbit. Okay, next one. So if the body having the velocity in between root gr and root 2 gr, the velocity is in between root gr and root 2 gr, then the body follows the elliptical orbit. Then the body follows the elliptical orbit. Then the body follows the elliptical orbit. Okay, so if the body is having the velocity exactly equal to root over 2 gr, you know well, when the body is having the velocity exactly equal to root 2 gr, what happens? It enters into the space. And by following the parabolic path, escapes from the gravitational force, and follows the parabolic path. Space. Okay, next one. So if the body is having the velocity greater than root 2 gr, then it now also the body enters into the space, escapes from the gravitational pull, and enters into the space and follows the hyperbolic path. These things you need to know. When the body velocity is different, then what happens to the particular paths of the body? Okay, and now this is about escape velocity, orbital velocity, and energy of the satellite. Okay, and now I'm taking another topic. I'm taking another topic, and that is gravitational field intensity. What's that? Gravitational field intensity. Gravitational field intensity. Okay, so what is the gravitational field intensity that we are representing with easy? Easy is equal to the gravitational force per unit mass is known as gravitational field intensity. The gravitational force per unit mass. So what is the gravitational force? G capital M small m by r square by m. Then you will get that Gm by r square is the gravitational field intensity. Gravitational field intensity. Okay. So now with that, how come we consider the, with that we are taking another one, that is gravitational potential. Gravitational potential. What is the gravitational potential? The gravitational potential is nothing but V is equal to, here gravitational field intensity, nothing but E bar dot dr bar. V is gravitational potential is a scalar physical quantity. So the dot product of the two vectors is a scalar. E bar is one vector, dr bar is another vector. So V bar is equal to, how come you consider that? E bar dot dr bar. E bar dot dr bar. Then this value also we are taking like this also, like this. V is equal to, in the form of integration, minus E bar dot dr bar. Okay, like that we consider the gravitational potential. For example, here gravitational field intensity, again E, gravitational field intensity also taken as dV by dr minus dV by dr. The negative gradient of potential is known as gravitational field. The negative gradient of potential is known as gravitational field intensity. E is equal to minus dV by dr. If you know the gravitational potential, if you differentiate, then you will get the gravitational field intensity. If you know the gravitational field intensity, if you integrate, then you will get the gravitational potential. Okay, so based on this, we have a number of models. Okay, like this, we can consider the gravitational field intensity, gravitational potential, escape velocity, orbital velocity, and energy of the satellite.